So now we are going to plot the image fig, and here, because I want to plot both the image, I will do AX1, AX2. So far you guys have just used like one plot, but here we are going to create multiple plots because I want to compare side by side. And so plot subplots, and in here this n rows equals how many rows do I want? One row. And n calls, that is number of columns in the subplot, is going to be 2 because I have two images that I'm going to show at the same time. Then fig size, I'm going to make it wider because there are two plots, not that wide, 24 by 12. And now I'm going to create two variables. First is image 1, and that's the 2000 that I'm going to plot. So I would say rio.plot. Before I start plotting, raster Rio does not automatically load its plotting function, so I have to import the plotting function from raster Rio import plot. And then so image 1, back to plotting the image 1, rio.plot dot show, and here it's going to plot the 2000 and AX in the first AX1, that's the first subplot. And then the C map, I'm going to use the yellow, orange, red, the same color scheme as we saw in the land scan map. And the title of this subplot is going to be 2000. And I'm going to copy this line of code for image 2, and in here update it for 2020, and here 2020 as well. So something went wrong, that the next plot is not showing up here. Oh, I did not change this to AX2. Okay, now I can see my plots here. This is the 2000 population density and this is the 2020 population density. So you can see the increase in the population. So the first question is where it has increased. I mean, we can see, but it would be nice to have just an image showing the increase and the not like no change. Let's create a new variable sub, and I will say 00_20. So that means I'm going to subtract the 2020 image or 2000 image from the 2020 image. And here you can directly like do your subtraction. You don't have to write sub because this is a different data model. This is image data. And then I'm going to plot it, but let's run this to make sure the code works. Okay, now that the code works, let's add the plotting function. Here as well, I'm going to write fig AX, and here it's going to be one plot, so subplots and size and equals to, let's make it big so that we can see the change, quite detailed changes in there, but there is just one plot, so 8 is fine. And then I'm going to add Rio plot show here sub 20. That's the data set. AX equals to AX, and C map, I'm going to do red and blue. Red areas like too extreme, it's just nicer, and let's see what it looks like. So here it is. You can see the red areas are areas where there was no change really, or decrease maybe, and blue areas where it increased. If you look at these maps from 2000 and 2020, I say there is no population decrease, and that's true, but you can see in this specific location Actually, there was a decrease, but it kind of spread out rather than being fixed to one location. So overall, maybe if you take the whole image, there wasn't decrease, but pixel wise, there was decrease, and that's what this is showing in here. Finally, once we have seen where population has increased, now let's look at how much. So for that, we're going to create histogram, and same as the plot, raster does not load the histogram function directly, so we have to import it again, and this time it's raster.plot import show hist. Okay, so now I'm going to start with the plotting function again, so fig, and this time I'm going to show 3 histograms, so 2000, 2020, and the change. Okay, so let's do AX1, AX2, and AX3. Then I'm going to do plot, subplots. Then in here, n rows is going to be 1, and n calls is going to be 3, and I'm going to do this share y because I only want one y-axis to be labeled and not all of them. Size, let's make it wider, 15 by 4, that's the height. And now let's plot individual histograms. So show hist data 2000 AX, and this will be the first one, AX1. Bins, this is histogram, so we have to define how many bins we want, 10 of them. Density, and 10 is really my starting value. I can change it if I want. And then density, true, title is going to be 2000 histogram. Okay, now I'm going to copy paste and update for other images. Okay, so this is going to be 2020 AX2, and this is 2020, and the last one we know the name. The name is sub. I'm going to just copy paste so that it's not incorrect, and this is AX3, and density 2, and this is change from 2000 to 2020, or maybe you can just call it histogram difference. Okay, something is wrong. Oh, fig size equal sign. So something is wrong here. Okay, I did not give the parentheses, and now we have this chart. However, I don't like these labels or legends that it has automatically added. So what I'm going to do is remove the legend. So AX1, get the legend. First we have to get the legend and dot remove. So this is the syntax, and I'm going to run it for the other ones too, AX2, AX3, and let's see. So now we have the histogram, and we are going to save this fig.fig, and this is hist.png. Okay, so that's it for the histogram plotting. So now you can see that the higher number of pixels are in this range. So this is showing the number, or it's called DN, so the value of the pixel, digital number. And it's mostly within this 10,000 mark. So the majority of the population is with, like, per pixel population is 10,000. Similarly here as well in 2020, it increased a little bit in the higher numbers. And when we see the change or the difference, we can see it's actually a lot in the lower, like negative areas, where and then these are the positive areas. So the negative areas are those areas where the population has decreased, and that's because 2020 to 2000, the spread out has been higher, so that's why some pixels may have lost population, but overall, and that's why the spatial versus the histogram analysis is important, because in histogram we see population decrease. It's not saying or showing us that actually it may have decreased from an individual pixel, but now we have bigger spread of population.